Hi students, today we will learn our last lesson in our right triangles unit. We will talk about trigonometric ratios, which are commonly referred to as just trig ratios. So trig ratios can be used to find missing side lengths or missing angle measures in right triangles. So the cool thing about this is that it's all done on the calculator for the most part. So you definitely will need your calculator. So pause the video and go grab your calculator if you don't have it. But it also works with just right triangles. Trig ratios are very applicable to real world. So I'll show you an example in class. But a trig ratio, remember what a ratio is. A ratio is a comparison of two numbers. So the ratio is going to be composed of the lengths of the sides of any right triangle. So we're not talking about special types of right triangles anymore. And these ratios are related to one of the two acute angles in the right triangle, and I'll explain what that means. But you might just want to write yourself a note related to the acute angles. Okay, so first we're going to learn about the ratios, and then we'll learn how to use them in a problem situation to find a missing side or a missing angle measure. So the three most common types of trig ratios that we'll be using are called sine, cosine, and tangent. There's also cosecant, secant, and cotangent, but we won't learn about that this year. You'll learn about that in pre-cal. Trig ratios are definitely used in pre-cal as well, so make sure that you're learning this well. So we're going to learn about what these ratios are for sine, cosine, and tangent, and how to find them from a triangle. So on the left, you've got just a basic right triangle. We've labeled the sides A, B, and C. We've labeled the vertices A, B, and C, just so we can refer to parts of the triangle. In the top half of this table, we are going to be working from angle A. Okay, so everything will be with respect to the location of angle A. And then in the bottom, we'll switch to angle B. So first of all, if I need to find the sine of A, the abbreviation, we abbreviate sine to just S-I-N, we just drop the E, but it's not pronounced sin, it's still pronounced sine, and then we put the letter of the angle after it. This can be the letter, or it can also be a symbol that represents the angle itself. It could also be the measure of that angle, where you could put right here. So the actual definition of sine is opposite, whoops, I'm going to abbreviate opposite over hypotenuse. So let me explain what that means. From angle A, the side opposite it, if I draw an arrow from it, would be side A. I'm going to put an O there that represents opposite. The hypotenuse is always the hypotenuse. The hypotenuse is always across from the right angle. So side C will always be the hypotenuse, just like it is when we're doing Pythagorean theorem. Okay? So if I wanted to make the ratio of the opposite side to the hypotenuse side, I would take little a, which represents the opposite side, over little c, which represents the hypotenuse side. And that would be its ratio. The ratio of sine A is A over C. The cosine of A, first of all, it's abbreviated as COS. And we still say cosine, we don't say cos. These abbreviations are how you'll see them in your calculator. Okay, that's why we're trying to teach you the abbreviations. The definition for cosine is adjacent side over hypotenuse. So I'm abbreviating both of those. Oops. So from angle A, the adjacent side it's really the adjacent leg. That's going to be side B right here. So these are the three sides with respect to A. We've got the opposite side, the hypotenuse, and the adjacent side. Notice the adjacent side actually touches angle A. Okay? All right, so the ratio of the adjacent over the hypotenuse, the adjacent side is letter B, and the hypotenuse is still C. So B over C is the ratio for the cosine of angle A. Tangent of angle A can be simplified to just tan. That's how you'll see it in your calculator, still pronounced tangent. And the definition of tangent is the opposite side over the adjacent side. So the opposite side was A, and the adjacent side was B. So A over B is an example of the ratio for the tangent of angle A. So when you think adjacent, adjacent means next to. I think that gets students mixed up the most. So the adjacent leg is the one that's touching the angle. The opposite leg is the one that's across from it. And then, of course, you know the hypotenuse. So that's for angle A. Now we're going to go ahead and switch to angle B. So I'm going to use green for these. So kind of ignore all of the purple. We're going to focus on green. So the abbreviation of sine of B, cosine of B, and tangent of B is going to look a lot like it was up here. So sine of B, cosine of B, and tangent of B. The definitions are still the same. Opposite over hypotenuse for sine, adjacent over hypotenuse for cosine, and opposite over adjacent for tangent. Okay, so let's go back to our triangle. So from angle B, we're going to rename our sides with O, A, and H for opposite, adjacent, and hypotenuse. Now the side opposite angle B is this side. This is our opposite side. The adjacent side is now this guy. This is the side that touches it. And then the hypotenuse is still the hypotenuse, right? So that doesn't change. So if you notice, when you change angles, the only thing that really changes is the opposite and the adjacent get flip-flopped, okay? So let's see, how does that affect our ratios? So the sine of B, since it's opposite over adjacent, opposite is B, adjacent is A. B over A. Okay? Cosine, opposite over hypotenuse. I misspoke. I thought that didn't look right. Opposite is B, hypotenuse is C. Sorry about that. Cosine is adjacent over hypotenuse. The adjacent side is A, the hypotenuse is C. And tangent is opposite over adjacent, so the opposite side is B, the adjacent side is A. Now what I want you to do is see how these ratios in green compare to the ratios in purple. What you should notice is that the sine of A, let me get a different color. The sine of A is the same as the cosine of B. These are equivalent. You should also notice that the cosine of A is the same as the sine of B. These are equivalent. And that's because the opposite and adjacent sides flip-flopped, right? The denominators are all C because the hypotenuse didn't move. Notice the relationship between the tangents. They're reciprocals of each other. They're reciprocals, R-E-C for reciprocal. So as you do this, you're going to notice some of these patterns. All right, so let's try this with an example. Before we do that, though, I'm going to share something with you that is going to help you remember these definitions. Okay, and it's called SOHCAHTOA. SOHCAHTOA. And if you look at it, you could probably figure out what it means. But what this means the so means that the sine is opposite over hypotenuse. The ca means that cosine is adjacent over hypotenuse. And the toa means that tangent is the opposite over adjacent. I also had that on the front of this video. So I use that to kind of help me remember, because it is easy to forget. But if you remember so, ca, toa, and you write it down when you do these problems, it'll help you remember how to make these ratios. Now let's try a problem. Okay, in this example, we're doing the same thing we just did in that last table. We're finding the sine, cosine, and tangent from angle A's perspective, and then the sine, cosine, and tangent from angle B's perspective. So at the bottom of my page, I'm going to go ahead and write my SOHCAHTOA, and then I'm going to go ahead and set it up. All right, let's first start from angle A. Okay, so the first thing I always like to do is label my opposite, adjacent, and hypotenuse sides. Remember, the opposite side is across from that angle. The hypotenuse is always across from the right angle. It's the longest side. And then the adjacent side is always that leg that touches the angle. All right, so here we go. So now we're actually using numbers for the OA and H. We've got 5, 12, and 13. So let's go ahead and start with sine. Sine is opposite over hypotenuse, or O over H. So we're going to do 5 over 13. Cosine. Cosine is A over H, or adjacent over hypotenuse. So we're going to do 12 over 13. And then tangent is opposite over adjacent, or O over H. So in this case, 5 over 13. All right, now let's do it from angle B's perspective. Again, let's go ahead and relabel our sides O, A, and H. Now remember, our H is the same. The only thing that happens is our O and our A flip-flop. So make sure you're focusing on the green letters now. So remember, sine is opposite over hypotenuse, or O over H. So we're going to do 12 over 13. Cosine is A over H. Look at the green letters. That's 5 over 13. And tangent is O over A, or 12 over 5. Okay. Just like before, notice how these relate. These two are equal. These two are equal. And then remember, these two are reciprocals. They're flips of each other. All right, so now I'm going to have you guys try one on your own. So go ahead, pause the video, see if you can find the sine, cosine, and tangent from angle S, and then also from angle E. And then when you're done, press play and see how you did. All right, here are the answers. See how you did. Now we're going to go ahead and create the equations to see how to find any missing sides or missing angle measures of a right triangle. Okay, this is where you'll need your calculator. Before we get started, I want you to go to your home screen on your calculator. You're going to click 5 for settings, and then 2 for document settings. Look at where it says angle, okay? Look at where it says angle. It needs to say degrees. It should not say radians or gradians. Believe it or not, there's a lot of different kinds of angles. We're only working with degrees here. So if it says radians or gradians, all of your answers are going to look crazy. Make sure it says degrees, okay? Now we're able to go. So we can set up equations to help us find the missing side lengths or the missing angle measures. Now the only angle measures that would be missing would be one of the acute angles, because you have to have a right angle, so you know that you have the 90-degree angle. So over here on the left, this is kind of how you would set up your equation to find any missing side lengths. Okay. And so in this type of example, you're going to know one of your acute angles. So right here is where you would put the degrees of your angles. In your ratio over here, one part of your ratio will be a variable, okay? You're going to choose the appropriate trig function based on what you know. And I'll explain how this works when we do a few examples. So an example of what this could look like, of course this is just an example, you might have an equation that looks like this. Sine of 63 degrees equals x over 5. Okay, that could be a possible equation. Okay, and then I'll teach you how to solve that. The setup on the right, this is what it'll look like when we're trying to find missing angle measures. Now the cool thing about finding missing angle measures in a right triangle is if you find one of the acute angles, you know the other one because it adds together to equal 90. So the way this works is this symbol right here, this theta, that represents an angle measure. That's why over here we put the actual measure of the angle. But over here on the right, we don't know what it equals. So that's our variable, basically. That's what we're trying to find. Then we're going to choose one of these trig functions, but these are actually, these are inverse trig functions. So it's basically doing the opposite of what we're doing on the left. I'll explain that when we get there in our calculator. And then, of course, the ratio of the sides are going to be two numbers that you know the side lengths of. So you have to know two side lengths in order to find a missing angle measure. So an example of what this type of equation might look like might be like this. Inverse sine, I'm going to start with the angle measure. Angle measure equals, or you could have an x there if you don't like that theta symbol, inverse sine of my ratio, so maybe 3 over 5, something like that. And then you would type that into your calculator to get the angle measure. So now we're going to do some examples. First we're going to do a set of examples where we find the missing side lengths, and then we'll do a set of examples where we find the missing angle measures. Alright, in these examples, we're going to do 4 where we find the missing side lengths. So this is going to be using that equation template that was on the left of the last slide. So the very first thing you want to do, it looks like we're trying to find this side x right here, right? The first thing you want to do is you want to choose one of the two acute angles. You'll never choose the 90-degree angle. Okay, notice we didn't ever use that in the first part of the video. So you'll choose the 21 degrees or the 69 degrees. Let's go ahead and choose the 69 degrees. It doesn't matter. I'll show you both ways. So let's say we choose the 69 degrees. From that angle, we're going to label the sides that we know and that we're trying to find. So the x, since it's the leg that's touching it, that's going to be my adjacent side. The 9, since it's across from the right angle, that's the hypotenuse. I don't need to do anything over here, okay, because we're not concerned with that side and we don't know that side. So the two sides that I have are A and H. This is where SOHCAHTOA comes in really handy. So go ahead and write it down on your paper somewhere. So I'm going to look at my SOHCAHTOA and I'm going to say, okay, I've got A and H. Which one uses A and H? It's the middle one. It's cosine. That's how I know which trig function to use. So here's how we set it up. We're going to write the trig function we choose, cosine. We're going to write the angle measure that we've chosen, 69 degrees, equals the ratio. The ratio for cosine is A over H, or x over 9. So here is the equation. I'm going to write it down here. Okay, so now all we have to do is solve this equation. Just like any equation, you want to isolate x. To get that x on the right by itself, I've got to get rid of that 9 that it's being divided by. So to get rid of dividing by 9, I'm going to multiply both sides. Oops, I'm going to multiply both sides by 9. Okay, these 9's cancel, so we get x equals, or I can do it this way. On the left, we've got 9 cosine of 69 degrees equals x. So all we have to do is type this into the calculator part of your calculator. Now the cool thing with trig functions is we don't have to worry about any of these radicals. All of our numbers are going to be decimals. So you just type in 9. The way you get to the trig functions is right next to the 7. There's a trig button. Press trig, click on cosine, type 69, enter, and it gives you a number, and we'll round. Let's go ahead and round to 1 decimal place, about 3.2. So that is about the length of this missing side over here, about 3.2. And I should put the wiggly equal sign, which indicates that we've rounded. Okay? Now, let's say that I had chosen to go from the 21 degree angle. Okay? So now the sides that I have, the x is now the O, and the 9 is still the h. O and h means we would be using SO, or SOHCAHTOA. SO stands for sine. So I could have a different equation that looks like this. Sine of angle 21, remember sine is O over h, is x over 9. And then I could use this equation instead. I would still solve it by multiplying both sides by 9, which is basically going to say that x equals this. Now if I type that into my calculator, I should still get the same answer. So remember, cosine from one angle equals sine from the other angle. Remember we learned that on the other page. So you choose the angle that you want, basically. Moral of the story. All right, let's do B. So B, we're trying to find x. We can choose the 37 or the 53. Let's try the 37. Okay. We're going to label the sides that are labeled with O, A, or H. The x is the adjacent leg, so I'm going to put an A. The 13 is the hypotenuse. I look at my thing, A and H. Again, that's ca. The C stands for cosine. So I'm going to write cosine. I'm going to put the measure of my angle, which is 37 degrees. And that equals the ratio for cosine, which is A over H, or in this case, x over 13. So there's my equation. Rather than rewriting it, I'm just going to put a box around it, make it a little bit easier. Now to solve it, I just have to isolate my x. So we're going to first get rid of that dividing by 13 by multiplying both sides by 13. So x is about equal to whatever this is in your calculator. 13 times cosine of 37. And you get about 10.4. Remember, we're going to round to 1 decimal place. So this is about 10.4. That's the length of that side. All right, let's try some more. All right, in these two examples, we're still solving for missing sides, but now we're solving for both missing sides. Okay. Now notice in these, they've only labeled one of our angles measures, so I suggest just use that one. If you really wanted to use the other one, you could subtract that from 90 to get the measure of the other angle and use that one, but I just suggest using the one that's given. So from that angle, we are going to label our sides with O, A, and H. The opposite side, the O is the x, the adjacent leg is the y, the hypotenuse, which is the side across from the 90, is my 8. Again, you might want to write SOHCAHTOA on the top of your paper. I would just get in the habit of doing that all the time. All right, so let's go ahead and solve for the x first. So the x, I want to use the side that has x, which is the O, and then I want to use also the side that I know the length of, which is the 8. So we're going to kind of ignore the y side for right now. So on those two sides, I've got O and H. O and H is So that's sine. So our equation will be sine of my angle measure, which is 36, equals my ratio, which is O over H, or X over 8. Okay, so there's my first equation. Okay, I'm going to write my two equations first, and then I'll go ahead and solve them. My equation for the y, we're going to focus on the side that has y and also the side that we know the length of the 8. So we're going to ignore the x now. So we have O and H. Now that's, O and H is also so. So we're going to use sine again. I'm sorry, A and H. I'm confusing myself with A and H. So we're going to use ca this time. The C stands for cosine. So cosine of our angle measure, which is 36, equals the ratio of A over H, which is y over 8. And this is my second equation that I'm going to use to solve for y. So now we just have to solve these little guys. So they're both going to actually be solved the same way. We're going to start by getting rid of that 8 in the denominator on the right side by multiplying both sides by 8. So x equals about 8 times the sine of 36. Type that into your calculator. I got about 4.7. So that's about the length of side x. On the right side, we're going to solve the same way. We're going to multiply both sides by that 8. Don't have a lot of room here. And y is going to be about equal to 8 times cosine of 36. Type that into your calculator. It's about 6.5. So that's the length of, about the length of that missing side. Okay? If you want to pause the video and try to do D on your own just to see, then you can unpause and see how you did. Alright, for the x, you should have gotten sine of 50 equals x over 11, and x is about 8.4. For the y, your equation should be cosine of 50 equals y over 11, and the y is about 7.1. So if you didn't quite get that or have any questions, go ahead and jot a note and you can ask me in class. So in these examples, we're going to go ahead and find the missing angle measure. So the process is kind of the same. The way we're going to create our equation is going to be a little bit different. So first we're going to identify the angle that we're trying to find the measure of, and that's this angle over here, x degrees. And then we're going to label our sides that are labeled with O, A, and H. You should know two sides. So the 4 is across from it, so that's your O, and the 10 is the hypotenuse. So in this case, O and H means that we should be using sine. So here's how we create our equation. It's going to be, we're going to start with theta. That just means, or you could use x, that's just the angle measure you're trying to find, equals, because we've chosen sine, because we have O and H, we're going to put the inverse of sine. So the one with the little -1 at the top, that's what you use when you're trying to find angle measure. And then right after that, you're going to put the ratio for sine, which is O over H, or in this case, 4 over 10. These are actually a little bit easier. All you have to do now is type this part into your calculator, and boom, that's going to be the angle measure. We're going to go ahead and round to, let's round to 1 decimal place again. Or no, let's round to the nearest whole degree. So in your calculator, you're going to press the trig button next to the 7. And below sine, cosine, and tangent are the inverse sine, inverse cosine, inverse tangent. So make sure you're clicking on the right one. It'll pop up some parentheses, and that's where you'll write the ratio of 4 over 10. And you can just do 4 divided by 10, or you can set it up as a fraction. Enter. It is about 24 degrees. It's so easy. That's all you have to do. So if I know that this angle measures about 24 degrees, I can subtract that from 90 to get this angle measure, which would be, what is that, 66 degrees. Right? So if I can find one angle, then I also know the other one. All right, let's try another example. So in this case, we're trying to find the measure of this angle. The sides we have, the 7 and 2. The 2 is our adjacent side, the 7 is the hypotenuse. Now we have A and H, that's cosine. So the way we're going to set up our equation, the angle measure we're trying to find is going to be equal to the inverse cosine of the ratio for cosine, which is A over H, or in this case 2 over 7. So you're just going to type this part into your calculator. Inverse cosine of 2 over 7, enter, and it's about 73 degrees. Super simple. Let's try a couple more. All right, here's a couple more and then we're done. So we're trying to find this angle measure X. The 10 and the 15 are the O and the A. O and A is TOA. So we haven't used tangent yet. So T is for tangent. So we'll write X for the angle measure we're trying to find is going to be equal to the inverse tangent of the ratio for tangent, which is O over A, or in this case 10 over 15. Type this into your calculator. Inverse tan of 10 divided by 15, and it rounds to about 34 degrees. Woohoo! Got one more. If you want to try D on your own, you can go ahead and pause it right now and then unpause it when you're done. Okay, so this is the angle measure we're trying to find. 3 is our opposite side, 20 is our adjacent. Again, that's TOA. O and A is TOA, so that's tangent. So our angle measure is going to be equal to the inverse tangent of the ratio for tan, which is O over A, or 3 over 20. So go ahead and type that into your calculator. 3 divided by 20, and you get about, this is a very small angle, about 9 degrees. 8.5 rounding up to about 9 degrees. All right, so bring your questions to class. I bet you have a little bit more questions about how to solve for missing sides. We're going to do a couple in class about how to solve for the hypotenuse, which is just one extra step. All right, see you soon, or see you next time.